All right, in this video, we're going to talk about charting numerical variables. And really what we do here is we use what's called a line chart or a scatter diagram. But the main thing to remember first is with numerical videos is that those values could go on forever. So a lot of time we're looking at performance when we talk about numerical variables. So a group of test scores, a group of heights or weights, or especially times, how fast it takes someone to do something. So first we need to figure out how we're going to group those scores. And let's just take a simple set of data where it's a test score. And so we have one class, a group of people in class 1, and these are the variables. So we have test score, and then in this column would be number of Spartans that fell into that group. And so for the example of this graph, we're going to say that 60 to 69 falls into this first group, for example, and then 70 to 79 in this particular group. So we have 5 groups, and the interval, meaning the group size of each, is 9, essentially. And so we'll say it looks something like this. Okay, and just to refer back to some habits that we're developing, we always want to take that sum down here so we know the total that we're talking about. And we're going to go ahead and take the frequency. So we take that number within the group divided by the total. We're going to lock that total down. We're going to drag this down, and we're going to clean this up. So that's what it looks like. Now, just for this one, we're going to look at cumulative frequencies. So for the first cell with numerical values, we can just make that equal the cell of the bottom group. In this case, it'd be 0.05. So that's these 4 Spartans that scored between 60 and 69, but not 70. And so that was 5% of the total group of the total 76. Now for this cell, we can just add this cell plus that one. So what this is saying is that this 51% accounts for both this group, the group that scored between 79 and 70, and the group below it, 69 to 60. So what this is saying is that 51% of the group of the 76 of this class scored 69 or 79 or below. That's what that is saying. Okay, so if we drag this down, we'll see, well, 80% of the class scored 89 or below, that kind of thing. So we can kind of see how this moves up. We see that here, 46 plus 29, so 85% of the class scored between 89 and 70. Okay, so that was where the majority of students scored there. We had some outliers down here. We had a few outliers here. But the majority of folks scored right there. So, but this doesn't talk to us about how to graph that. So there's a number of ways we can graph this. First, we can graph it. We're going to want these values on the x-axis and um, these values on the y-axis. We could do it that way. So we want to get a graph in whatever software we're using that reflects that. So let's just try a line chart. And that doesn't so much do it for us. Let's see if we can alter this by selecting the data. So that still doesn't entirely do it. It gets us closer. But this doesn't tell us. This just tells us the number of groups. So let's see if I can try this again. So there we go. This tells us that 5 people, or 4 really, scored in that group. 35 scored here in that group. So this chart, it shows us a little more visually. The point of the chart versus the table is that it shows us where the central tendency and the bulk of people scored. So here we can see it mathematically. Here this helps us visualize a little bit more. This, and just by looking at this, not too many people scored out here. The majority of people scored really between 70 and 80. So not too bad performance. Now, if we copy, so in other words, let's say we do this. Let's just copy this whole thing down here. So if we copy these numbers down here, and what I did was eliminate the number column. What I'm going to do over here is create what's called a frequency polygon, which is really a fancy way of charting, saying that we're going to chart these numerical values. So I'm going to try the same method here. First, I'm going to insert that chart. I'm going to go with a line. And again, this isn't really the way I want it. So I'm going to have to do the same kind of adjustments that I did before. First, I'm going to get this so we can just see it on the screen. I'm just going to move this out of the way for a second so I can bring this up a little more. Wow. Okay. Okay, same kind of adjustments. I want these to be my values on the x-axis. I want these to be my values on the y-axis. And my range is going to refer to my y-axis. Notice I don't want to use the cumulative frequency. That's not really going to help me out. When I put this in up here, for some reason it drops that out, so I need to put that back in. Again, not the most efficient way to do this, but the result is what I want. Now, here's what's interesting, and this may or might not be intuitive to you, but as we look at the shape of both of these graphs, so this one up top is charting this data, same X values, same grouping. This one is charting the number of students that scored in each category or each group. Okay, peaking out at about 35. And remember, this D column of frequency is this column down here. So in essence, these charts look just about the same. And the only reason they look different is because probably in here I have the dimensions of these charts differently. So if I pull this one down a little bit, see how it doesn't look so much. But if I pull it up, it pretty much does. And that's because they are the same. The y values in respect to these y values are the same proportionally. So we call this bottom one a frequency polygon, a fancy term because these are frequencies. These aren't frequencies that are a number of students, but it's the same thing. So when you do frequency polygons and work in this class, this is the way you want to do it. This is what the chart should look like, maybe not necessarily the way that you arrive at the chart. Now let's just go to another sheet quickly, and let's see if there's a better way we can do all this. Okay, so let's free up some space here and here. Okay, so a scatter plot is, we usually use a scatter plot when we want to see how one variable changes in relationship to another one. So, for example, let's say that I have the weather. And let's say I have temperatures for the weather, colder, hotter, and of course weather is a numerical variable that's continuous. Okay, weather could be 40 degrees, 0.11111, or it could be 50 degrees, anywhere in between. So as weather increases, let's say I want to know how many cookies I'm selling down at the cafeteria, if there's any kind of relationship. And I have some data that, let's just suppose that I only have 1, 2, 3, 4, 5, 6 days of data. And as unrealistic as it sounds, these were the temperature on each of those 6 days. And again, in reality, over 6 days, I don't think the temperature would vary from 40 to 90 degrees. And I surely don't think it would come out as evenly as this. So there's a little artificiality in this example. But let's just say that I sold 655 cookies here, 443, 267, 123, 189. So just by looking at this, I can see that as the temperature goes up, the number of cookies I sell goes down. This is a pretty strong correlation, positive correlation. And so what we want to do just to further tell the story is we want to show that graphically. So we're going to choose an XY scatter. And that shows as temperature goes up, the number of cookies we sell goes down. Now, because in this data, let's suppose that it was, we rounded or we put these into groups. So we actually could draw a line. So we go to change chart type and we kind of look at the options we have. And we could choose something like that, which better tells the story. So right there, again, as temperature goes up, number of cookies goes down. And that helps us make a decision how many cookies we're going to make, maybe during the summer period, during the spring period, during the winter period. And then maybe how we're going to market those cookies. Hey, you know, having trouble with the cold, come on inside, get a nice warm cookie, that kind of thing. So what does that have to do with stuff that we've already covered in this video? Well, going back to this data, we could use that same type of approach to chart this data right here. So let's give that a shot. Let's go to Insert, Chart, and let's go down to XY Scatter. And so here we have those test scores on the x-axis, and we have our frequencies on the y-axis. So if we went back here to chart, XY, or actually over here to change chart type, and we could look at those options, we could, in essence, connect the dots, and that would give us this. There's probably a more refined way to get rid of this 120. I don't know why it appears, because it's not on a range in these values here. But if we flip back and forth between this shape and these shapes, acknowledging that we need to stretch this graph out a little bit, and that's why this looks like more of a drastic peak here. But the general shape between this graph and these set of graphs are the same. So put another way, that is also, we can alter this. We go in here, format axis, and instead of 0, let's say we have the axis end at, we'll just say 50. So that's going to give us a spread a little bit more. Instead of 110, let's have it at 105. Get out of there. So that starts to look a little bit more like this graph. So whatever way that you go to it, depending on the software that you had, it doesn't really matter, as long as what we're doing is with continuous variable, a numerical variable, continuous measurement. We want to have that line, okay, because we know these scores could go between. We're not going to plot every individual score. We're going to group the scores and then plot the groups. And we want to be able to tell the story on where the majority of scores lie and what their tendency is. I always like the frequency table to just get us started. We can always fall back on that, make sure that our chart is saying what it's supposed to say. But I also like the chart as well to tell the story about what's going on. So in this video, I covered both the frequency polygon, which is what we're looking at right now. It's also the bottom graph here. This is not the frequency polygon. It is the distribution of scores. And then we also covered the scatter plot. Here, we looked at the relationship of two variables, weather and cookies. And here we had a negative correlation. We could have a positive correlation. So if we reversed this data, it turned out that 89 was at the bottom and 665 was at the top. Then that would say that As the weather goes up, the more cookies we sell. That would probably be more relevant or applicable to ice cream, for example. But the bottom line is that this is a scatter plot. This is using the scatter plot method in Excel to plot a frequency polygon. Okay. Here we don't have a frequency polygon. We have one variable, which is temperature, and we have another variable, which is the number of cookies. So it's important to make that distinction. This video talks about how to chart numerical videos or variables which are continuous.